Hey everyone, what's going on? Mark here from TST Industries, back in the garage for part 2 of our product feature on our integrated taillight for the Suzuki GSX-8S and 8R. Now, if you've watched part 1 already, you know that we went into a little bit of an extensive look into our integrated taillight, what went into designing it, addressed some common questions we received from customers, and took a look at what ultimately led to this integrated taillight. But here we are with part 2, where Bart will take you down a very deep dive and a very intricate look at what went into designing this light. All of the various lens components and lighting equipment that we went through, the design changes, removing your stock equipment, and then ultimately the finish line. So without further ado, I'm going to go ahead and pass it over to Bart. He's at his computer right now, and he will begin this journey. I hope you stick around.
Hop on board, guys. I will take you on an adventure now, delving into how we came about the design of this taillight for the GSX-8S and 8R. Anytime we embark on a journey like this, it first starts by conceptualizing what can be done on the motorcycle. Since these bikes come with a large tail fender, we wanted to get away from just stuffing a taillight in the OEM location, which is on the rear of the fender, and we took the challenge of replacing the center cap here, this original one, with a taillight unit that will fit precisely like this OE part into the bike. Now, when we start a project like this, we have to dismantle the bike and take all our measurements. Some of those measurements are done via 3D scanning. We will scan the entire bike in the location that we're working with. We'll scan individual parts, reverse engineer those components and make sure that they all assemble properly onto the bike. We make prototypes of the reverse engineered components to make sure we've actually hit that mark. Once we get to that point, we start sketching and figuring out how we are actually going to stuff a bunch of LEDs and optical elements into a capsule of such a small size. And then we start 3D design. Now, 3D design is really a long portion in the entire process of the project that leads up to the actual manufacturing and you guys receiving parts available for purchase. So that being said, we're gonna head on over to my design rig in my office. I'm gonna explain some of that there because I have a better setup to show you guys and demonstrate everything in detail. What I have here are components from the 8S and the 8R. We have the tail components here, and we have the fender. As you can see, all of the taillight and lighting equipment are on the fender, so when you want to remove your fender and go with one of the TST Industries fender eliminators we offer, you lose all of that lighting. So we had an intermediate package that moved all of this lighting to individual capsules. We call them Quadrix D. They had all of the functions, very bright, very nice, but we really wanted to make a non-retrofit look taillight system, one that basically looks like it belongs on the bike, like it's not an afterthought or a replacement for parts. We wanted it to look and function as though it was meant to be there from the start, right from the factory. And we are kind of known for that in the industry, so the stakes are pretty high, especially knowing that we have very, very little space. We decided to replace this component, this end cap, with our taillight. As you can see here, there's very, very little space to contain any circuitry and a molded capsule and all of that. So I knew right off the bat when I first saw this bike in February 2023 that this is gonna be sort of an uphill battle, but it kind of excited me. These challenges are like cornerstones that I look forward to. They're cornerstones of how we built this company. We don't back down from a challenge, and here I think we exemplified that behavior with the launch of our taillight. What you've probably seen on our website and in our videos is this taillight here. This is the final version. It replaces this cap exactly how it mounts in. I have a sloppy tail section here that's kind of been fixtured for the R&D process, so it won't fit the same as on the actual bike. But it actually replaces this cap pretty perfectly. It has all of the circuitry built into this tiny little space you see here we had very, very little volume in there to contain our board. So we have 4 separate circuit boards, and we also have our program button that lets you toggle through all the different programs, all the modes for the lighting. So the process to design this was actually very, very difficult and long, and I've gone through so many different revisions of this design and burned so many hours at night and weekends that I really feel like I need a break now. But I want to tell you how my mind put this design together. When I first laid eyes on the bike at a show, I saw really awesome symmetry on the bike and body lines that, if you imagine the flow of air over the motorcycle and form curves that meet and converge in some places and diverge in some other places, and look at the bike from the rear view, there is this duality of 2 symmetric components flowing with beautiful curvature, some angularity dispersed here and there, and it flows into this almost X look. The undertail, this component here, along with the pylon seat and this cap, when viewed from the back, from the rear of the vehicle, they form this cool, almost X shape. I wanted to capture that and accent it and capture the duality of the flow on each side and the symmetry. I wanted to make a dual taillight. Now, in this already tiny space, a dual taillight doesn't make sense. So what I did instead was I made a single capsule that is split cosmetically by this member here. It shrouds the entire capsule that's been built together with the lens, optics, all the circuit boards inside, and the enclosure, and it gives you this split look, further underlining that X duality and symmetry. In addition to designing this light to be aesthetically pleasing and congruent with the body language of the bike, we wanted to make sure that it hit some of the other paramount goals that we have for our equipment here, one of which is for it to be very bright. Now, to quantify that, brightness means meeting certain standards. SAE and ECE have standards that are laid out for taillight and brake light equipment to adhere to. So during the design phase, we use simulation technology to simulate the light output. We will actually model in the actual geometry of the LED chips along with the lens on the LED chips. We design our optics precisely for the output that we're looking for, and then we iterate that design until an appropriate design emerges that hits the parameters that we're going for. And here you see one of those simulations that yielded the latest optics. I won't go into the nitty-gritty of what these colors mean. Basically, what we have here is, after we actually built the taillight, built all the tooling that manufactures it, we sent it out to a test facility that does ECE and SAE tests, and we got it tested for taillight and brake light function, and all of the results passed. So we will be pursuing certifications where we can. The integrated version of this taillight is not certifiable, so we will be coming out with a separate version that has the same geometry, same light output, just omits the signaling equipment in the taillight. Now, let's jump in to some of the details here. Like I said, I had to put in a bunch of different circuit boards in here. I have 1, 2, 3 main circuit boards. This one is the computer board. You don't see any components on here because that gets populated downstream in a different software. Here is our intermediate board that provides light from these tiny little dots here represent chip on board technology, LEDs. What we do is we cut a metal circuit board and we send it out to a factory that populates individual semiconductor LED chips into these locations and then encapsulates that with a resin, and that solidifies and that provides an entire light field that outputs that bright light from this lower section here. This is a pretty cool technology because you can space them apart very close to each other, and you could, with the metal circuit board, you could actually dissipate enough heat so that you could drive them at really high current. So we're getting a lot of light out of this lower field here, and that looks pretty cool. It's also more solid there, but the main emitters are here. There's 4 per side, and those we wanted to have firing through this very nice lens array that we designed for proper projection. Now, these chip on board LEDs, they provide a very numb light output. It's not focused. It's basically just flood everything with light. All of the optics within the actual lens are designed to disperse that light and make it even. Here in the actual inner optical lens, we have the technology that takes the individual light beams from these 8 LEDs and focuses them in the appropriate location so that we can actually achieve the output that I showed before. And because of that, we're able to pass these tests. So a lot of work was put in just to make sure that we have proper output. Then we really needed to make sure that as this comes together, it actually matches the bike. So we chose the appropriate plastic to mold it in so that we can texture it and color it to be very, very close to all the components that it'll be in contact with. As you can see here, the undertail of this bike is very, very close in texture to our taillight, and then the color is pretty much a match. It's very, very difficult to make them a dead match unless you're using plastic from the same batch with the same colorant. So we got really, really close to the naked eye. It's pretty much dead on. And we also offer a closeout for this area that uses the same material and texture, so you can have this whole panel completely filled and smooth and beautiful. Most of our customers enjoy the ability to program their tail light on the fly and customize the light patterns that are available on the tail light. Now, for those of you that want to customize this, there is a button on the back. It does have a caption here that says program. This remains accessible under the tail. You take your seat off and you can press it under power. When the bike is on, you press it once and it toggles through to the next signaling light pattern version. So it goes from standard to sequential, and then it'll flash from the center out, and then it has something called pulsar. It basically fires a pulse and then shuts off, fires a pulse and shuts off at the frequency set by the relay. Then you keep pressing the button to access more of the brake functions. There are several different brake functions. We did go over that in our installation video. So if you want to see more details on that, you could reference that video. Next goal in the design of these taillights is to make it as user-friendly as possible. We wanted to make this as seamless as possible with the OEM setup, so obviously plug-and-play compatibility is a must. Signal connectors, main connector, you unplug your OEM equipment, you plug this in, you're good to go. Now, the best part of all is how quick this is to remount on the bike. 2 screws come out from here, 2 push fasteners come out from here. Take this off, put this in its place, it clicks in place, fasteners get replaced, this gets plugged in, and you're done. I think when I'm not talking while I'm installing, I can do this in under a minute. That just goes to show you how user-friendly that is. So all of those goals really add up. Once we hit them, actually, in the design process, they add up to a superior product. I really am proud of this particular taillight. It took over a year in development. It was a great challenge. I think I broke my brain several times on this one, but in the end, I ended up solving all of the challenges that we were faced with, and now we have a warehouse full of these things for you guys to enjoy. All right, guys, we're back in the shop now. The process that I just described to you, the entire concept to actual 3D design ready for manufacture process typically takes me, and it really depends on the complexity of the actual part. It takes me between 4 and 8 months. This particular one took a little bit over 6 months. We had a lot of negotiations going on between us and the optical engineer, coming back with different parameters that we needed to incorporate. Then the manufacturability, we already started consulting with the mold designer. A lot went into actually getting it to this form. What you see here is a rapid prototype made in 3D printing technology. I made all of the separate parts. I airbrushed them to make them look like they're gonna look in final form, or as close as I could get them to it. You can see it's fairly representative of the final unit. We stuffed it with the already designed and sampled circuitry that you see here. Really cool stuff. I really like this phase. I am an R&D guy, so this really makes me happy to start taking 3D geometry, making it into real components and assembling them, and then finally putting them on the actual bikes we own for use testing. So that was next. And as they go to use test, we start hopping into mold design. And what you see here is just one of the molds that we've developed for this particular unit. This light requires 4 different molds to make the 4 separate housing and lens and optical element units. This is fairly complicated stuff. This is a simplified version I have here. The mold splits and there's a cavity in it, the shape of the part. And you close it back up and put it in a big press that melts plastic and forces that plastic in. The plastic solidifies, pops open again, ejects the part, and it continues manufacturing it. Now, to make one of these molds, you have to buy a lot of different blocks of steel and pins and rods and all sorts of stuff. And I'm gonna hide some of the components here so that I can just show you the interesting part. A lot of the screws are not very interesting. So here I have the mold for the housing, the back housing, and the part that mates the entire light to the bike. Let me move one of the mold plates out of the way, and you'll see and basically have the reverse of the geometry of the part cut into this giant block of steel. And then there's some passages for melted plastic to get in. And then we have an insert here that we had to make separately so that we could actually make this mold and make it operate properly and have cooling passages in it. So there really is a lot that goes into melting plastic and shooting it into a form. And here you see the orange yellow part is the actual enclosure that we're trying to make. If we hide that, I'll show you the rest of the parts of the mold. I'm really only going to go through one of the molds. This is one of the more intricate molds here. It takes a lot of design time and then fine tuning to make sure that all of the features of the actual molded part can be made properly, because you have plastic shooting in and spreading within this tiny little cavity that's only 2 millimeters thick. It has to reach the end before it solidifies, and then this part actually has to eject from the mold. So all of the components of the mold have to have a draft angle so that they withdraw without catching on the part, and the actual design has to be assemblable in the end. So a lot of the complexity of it comes from just the multi-factor of the design aspects of this type of technology. So at this point, we are working with a mold designer to help us with this. I am not a mold designer. I understand a lot about this technology because I've been doing it for about over 20 years now. So I have a lot of input, but that actually goes to a contractor that does this for us professionally over and over. We've done a lot of work with him and we're very happy. So you can see the final units are very well made and they fit very precisely in the bike. So this is a very good technology for this particular application, and we continue to use it on our taillights. We're able to make optical quality reflectors that go inside and spread the light appropriately to hit the goals that we set and meet in our simulation. Now we actually have to make that fire out of our optics and meet the requirements that we've set. This particular phase of the process usually takes 2 to 3 months to design the entire mold package. Like if we have 4 molds, it will usually take 2 to 3 months to design them and then make them and then test them. Once we test them, we sometimes find that we need more fine tuning. Sometimes we need to rip one of the molds apart, maybe multiple molds, and repolish them. Not everything can be predicted in the design phase, so we actually have to have practical tests of the actual tool. So the last couple processes just take a few days. They're pretty quick. It's the actual assembly of all the components into the units. Like you see here, this is a final unit. And then quality control, making sure that everything is up to spec so that when you guys receive these, you are happy with them and they fit and function well. And then we also have to shoot a video showing you how to install it properly on the bikes. That happens at the very, very end, just before we go to launch. And after that, it's pretty much go time. Typically, we set a date at that point because we actually know that we can hit this date. At that point, when we set the date, people mark their calendar, and then during launch, we sit around and just watch what happens. It's usually pretty entertaining, and there's a lot of activity on the social media, so we like to interact with you guys while it's happening. It's a very exciting thing for us to launch a new part, and that is usually a party here in the office. So at this point, I really want to thank you guys, first of all, for enduring this long-winded video. So many people have asked over time for us to shed light on how these things are manufactured, how they're designed. So here we are. That's the video that's gonna tell you guys how this is done. Second of all, I want to thank you guys for being patient with us as we bring these types of technology to the market. It is a grand uphill battle sometimes, and those of you who are patient and send us kind words, it just helps us along the way. So thanks, guys. At this point, this has been out for a while. It's been doing great. A lot of people have taken pleasure in owning one of these and installing it. And now we're on to the next one, and we're already designing molds. So thanks again for watching. I had fun. I hope you did too. Check out tstindustries.com, and I'll see you guys in the next one.